Hi guys, it's Mrs. Bergman. Today's Tuesday, March 24th. I hope you guys had a great weekend. I really enjoyed getting to see your videos. The other day you guys did a great job. You can check your Spartan link to see those grades, but overall you guys did a really great job. I'm proud of you guys. Good job. Okay, so yesterday we began our new unit. It's Unit 4, and we're starting out with Section A, Probability and Statistics. So these are the 2 units that we are going to finish up the year with. These are things that you would do outside of pre-calculus, maybe what you'll do next year, or if you're going into college, maybe you'll take a class in one of these things. Next, we'll do limits and derivatives. That will be our last chapter of the year. Okay, so yesterday you started out by reading about using the multiplication principle of counting in Chapter 0, Section 7. I just want to review that with you really quick. Basically, this is saying that if you have 2 or more events, you can figure out how many total outcomes there are by multiplying the number of possible outcomes for each event. So it doesn't matter, you can have 3 or more events, even just 2 events, this will work, and you multiply how many outcomes or choices there are for each event together to find the total number of possible choices or outcomes. You also should have read about independent versus dependent events, and I'll go through those when I go through some of these practice problems. Okay, so these are some of your homework problems. Go ahead and check your answers for these, but I'm going to show you how to get the answers too, just in case you didn't get them right. So for the first one, number 2, for a particular model of car, a dealer offers 3 sizes of engines, 2 types of stereos, 18 body colors, and 7 upholstery colors. How many different possibilities are available for that model? So what I like to do is set out a line. So for each event, so event 1, they need to choose the size of engine. Next, for event 2, they need to choose the type of stereo. Event 3, they need to choose what body color they want. Event 4, they need to choose upholstery color. So I just like to make a list of my events so that I make sure I don't miss any. On the lines, what I like to do is put how many choices I have for possible outcomes for each event. So for the engine, there are 3 possible sizes, so I know there's 3 different possible outcomes for this event. For the stereos, there are 2 options, so there's 2 possible outcomes for choosing a type of stereo. Body color, there are 18 options, and upholstery colors, there are 7 options. Once I have the numbers listed for the number of possible outcomes for each event, all I need to do is multiply each of these numbers all together, and that will give me the 756 total possible outcomes. Okay, let's try another one. So this is a really common problem for these types of questions. Will often have to do with sandwiches or pizzas or stuff like that. So that should be a clue that you're looking at multiplication principle. So let me show you for this one. Our events we have are choosing a meat, choosing a cheese, choosing bread, and that's all my different events. Since I get 1 choice for each, I need to list how many different outcomes there are for each event. For meat, there are 12 different types of meat that I could choose. For cheese, there are 5 different types of cheese, and I can choose 1. For bread, there are 6 types, and I just get to choose 1. So I multiply these together to figure out how many total number of sandwiches there are possible, and you'll get 360 total possibilities. All right, number 6, your answer correct is 24. Here's how you get that in case you need some help. So our events here, we need to choose a crust. We need to choose a type of sauce. And since it says you're only choosing one topping, that's how I know this is a counting principle problem. That's my last event, is choosing one topping. So now I need to list how many possible outcomes there are for each event. For the crust, I have 2 possibilities. Sauces, there are 3 possible choices. Toppings, there are 4 possible choices or outcomes for the event. In order to get the total number of outcomes, I multiplied 2 by 3 by 4. So there are 24 possible pizzas. Okay, next, I think this is a little bit more complex, using permutations and combinations. I don't blame you if you were confused on this when you were reading it yesterday. I even sometimes still get these confused. You just need to make sure you remember which one the order matters and which one the order does not matter. So just pay attention to that and stick it to your brain so that you can remember. So for a permutation, this is when order matters. So basically this means like if you're putting something in order, so like a security code or the pin on your phone or putting up a batting order, this is when order matters. So there are 2 different formulas. If you're using all of your objects, you'll do NPN. If you're only using some of the objects, you'll do NPR. N represents the number of objects that you're putting in order or that you're choosing from. So let's say if you were doing like a batting order, if there were 20 kids on the team, N would be 20 because you have 20 possibilities of people to put in order. R represents the number of people or objects that you're actually going to take and put in order, or the number of spots that need to be filled. That's how I like to think about it. So like in your phone key pin, let's say that you're talking about just a normal 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That would mean that there are 10 different options because 1 to 9 and 0. There are 10 different numbers to choose from. And let's say your pin is 4 numbers. That means that there are 4 spots to be filled. So N would equal 10, R would equal 4 in that case. Let's go through another example problem. You did not do this one, so make sure you do this one with me. All right, so this one says, a door's keypad system requires a 4-letter code using the letters A through G. Each letter may be used only once. Part A, how many different codes are possible? So first off, I need to think about whether this is a permutation or a combination. I know that this is a permutation because I know that the order on this keypad system is going to matter. I can't put in one code and expect it to work the same as the same numbers in a different order. That's not going to work on a keypad. Talking about a security code. So basically, since I'm using the letters A through G, the number of possibilities that I have, let's think about it, A, B, C, D, E, F, G. So I have 8 different letters to choose from. So that means N is equal to 8. Next, I need to figure out how many spots I need to fill. So if you read the question closely, it says it's a 4-letter code, so that means R is equal to 4. So I'm trying to find 8P4. Now I need to show you a little trick. I don't know if any of you already figured this out, but on your calculator, if you go to the math button and you see probability up at the top, PROB, you should see choice number 2 is a permutation, choice number 3 is a combination, choice number 4 is a factorial. Since I'm doing a permutation, I'm going to click enter on permutation, and it was 8P4, so I'll type that in, hit enter. There are 1,680 different combinations here. Okay, well, turns out that I counted wrong. A through G is only 7 letters, so it should have been 7P4. That would help if I could count, which gives you the 840. So let me show you on here. I could go up, hit enter, change the 8 to a 7, enter. Okay, it's 840. All right, so there are 840 different codes possible. All right, part B says if a code is randomly generated, what is the probability that the first 2 letters of the code are vowels? So for a question like this, I know that it's still a permutation because it has to do with order and where order matters. But sometimes for this, I like to just set out my 4 numbers and think about how many possibilities do I have for each space. So for the first space, I want this to be a vowel. The second space, I also want it to be a vowel, A to G. The third and fourth can be any letter A to G. So for my first space, it needs to be a vowel from A to G. The only vowels from A to G are A and E. So there are 2 possible outcomes for this first event. The second one, if I've already used up a vowel in my first space and it says each letter can only be used once, that leaves me with only 1 vowel left over for the second space. After that, if I've already used 2 letters out of the 7, I have 5 other letters to choose from to fill in the third space. Once I've used 1 more letter, I only have 4 more letters left to choose from for the last space. So I have 4 possible outcomes for the 4th space in the code. Now to figure out how many possible outcomes total there are, I can treat this like a counting principle problem and multiply all of these numbers together to get 40. 40 is the number of possible different codes with vowels as my first 2 letters. However, they are not asking us for the number of different codes, it asks us for the probability. So just as a quick refresher, if you forget about probability, probability is always equal to the number of outcomes in your favor over the total number of possible outcomes. So for this one, the outcomes in our favor are talking about the number of outcomes where the first two letters of the code are vowels. So my numerator should be 40. My denominator, the total number of possible codes, is 840. 40 divided by 840 reduces to 1 over 21, which you could also put as a fraction, as a percent. Probability can be given as a fraction or a percent. But 1 over 21 is good. Just make sure if you're leaving it as a fraction, you reduce it fully. All right, next you also learned about combinations. In a combination, order is not important. So this is something where you might be taking a group of people. Let's say maybe I wanted to choose a group of students to take with me on a field trip. It doesn't matter whether I choose Sally first or Johnny first. All that matters is that they're both in the group that gets to go on the field trip. So the order is not important in this case. These are called combinations. The formula for a combination is here. However, just like before where there was a formula built into your calculator, this is also in your calculator under probability. So you have to click the math button, then go over to probability. And you should see NCR. I like to say this as N choose R. Again, N represents the total number available. R represents the number that you are going to actually take and put in order. So let's say out of all of my 120 students, if I could only take 20 on the field trip, N would be equal to 120, R would be equal to 20. Okay, let's try this first problem. This is one of your homework problems again. But I just want to go through it with you to make sure you know what you're doing. If you got the answer 4,845, you are correct. You can go ahead and skip through this problem a little bit. Otherwise, pay attention. Make sure you know what you're doing here. Okay, so this says, an art gallery curator wants to select 4 paintings out of 20 to put on display. How many groups of 4 paintings can be chosen? So in this one, the order doesn't matter because I'm just selecting a group of paintings. It doesn't matter whether I choose the Starry Night first or the Mona Lisa first. All that matters is that they are getting chosen to be put into the display. So I know this is a combination first off. That's the first thing to decide. Okay, so in this one, N is equal to 20 since there's 20 available paintings to choose from. And R is equal to 4 because that's all the number that I can take. So what I need to do is 20C4. I have 20 and I want to choose 4. Okay, so let me show you this on your calculator. You're going to hit, I like to type in 20 first. You don't have to do that though. Go to math, go over to probability. Hit enter. Whoops, wrong thing. Let's try this again. You don't have to hit enter for probability. You need to go down to NCR first, then hit enter. So it was 20, choose 4, enter. The answer is 4,845. All right, this is another homework problem. Let's go through this together. Go ahead and check your answers first. If you already have them, feel free to skip through this. Okay, the first one. First, let's see what we're talking about. 5 cards are drawn from a standard deck of 52 cards. The first one, A, says determine the number of possible 5-card selections. So for this one, it doesn't matter what order I'm putting the cards in, so I know it's a combination. N is equal to 52 because there's 52 total cards. R is equal to 5 because that's how many I'm going to put into my group. So what I need to do is 52 choose 5 on your calculator, and you should get 2,598,960. That's how many possible 5-card selections there are. Okay, part B. Find the probability of an arrangement containing 3 hearts and 2 clubs. So first of all, you should know that for each suit, there's 52 cards, there's 4 suits, hearts, diamonds, clubs, and spades. So 52 divided by 4, there's 13 cards in each suit. That's something that you need to know. Otherwise, you'll just have to do 52 divided by 4 each time you get a problem like this. Okay, so if I have 13 cards per suit, that means I have 13 hearts and 13 clubs. So what I'm going to do is I am going to treat this as 2 different events, hearts and clubs. Now, it doesn't matter which order I choose the cards in, so I know that it's a combination. Okay, for the hearts, N is equal to 13 because there's 13 possible hearts. And R is equal to 3 because I'm going to choose 3 of those 13 hearts. So in order to find the number of possible outcomes, I'll do 13C3. To find the number of clubs, I know there are 13 total clubs possible, and I only want to choose 2 of them. So N is 13, R is 2. So to figure out the number of different ways I can choose the clubs, I'll find 13C2. Now to find the total number of outcomes, I have to multiply the number of outcomes for the heart event times the number of outcomes for the club event, like choosing my clubs. So when you type that into your calculator, you can just type it all together, 13C3 times 13C2. And you should get that there are 22,308 possibilities for choosing 3 hearts and 2 clubs. Now, pay attention to your question though. It says probability. So whenever you're doing probability, remember you're taking the number of outcomes in your favor, which is what we just found here, over the total number of outcomes, which is what we found in part A, and when you reduce that, those are both divisible by 4. You'll get 5,577 over 649,740. That's one way to write the probability. The other way is as a percent. So if you just divide this out, you'll get a decimal. So this is equal to 0.00858. To change that to a percent, you multiply by 100%, which means you just move the decimal over 2 points. So it's equal to 0.9%. About. So the probability of choosing the probability of choosing 3 hearts and 2 clubs with your 5 cards is 0.9%. The next question, find the probability of an arrangement containing all face cards. So again, the order is not important, but you need to know about cards. So there are 3 different types of face cards. There's a jack, a king, and a queen. Let me add more space here. Okay, so what we'll do is figure out how many total face cards there are. So there's a Jack, King, Queen for every suit. So there's 4 suits. 4 times 3 suits gives us 12 total face cards. Okay, so if there's 12 total face cards and we are trying to get all face cards, what we're going to do is n is equal to 12 since there's 12 total to choose from. R is equal to 5 since that's how many spots we're trying to fill. There's 5 cards in the selection. So since order doesn't matter, it's a combination. So I'll do 12, choose 5. And when you do that in your calculator, you should get 792. But again, this asks for probability. So we're not finished here when we get 792. There's 792 total number of possible arrangements of all face cards. But since they ask for probability, 792 is the number of outcomes in our favor. The total number of outcomes is, again, the answer from Part A, the 2,598,000. So to get my probability, I'll divide this. If you want to reduce it, you'll get 66 over 216,580. Or if you change it to a decimal, you should have 0.0003, which as a percent, you multiply by 100, is 0.03%. So you only have a 0.03% probability of getting all face cards if you choose 5 cards out of the deck. So that's a pretty low chance. Okay, next part D. Find the probability of an arrangement containing 1 ace, 2 jacks, and 2 kings. Wow, I'm having trouble reading. Okay. So for this one, again, the order of the cards isn't important. So I know that I'm using combination again. Okay, first off, to deal with the 1 ace. Total, there are 4 aces in the deck, and I only want to choose 1. So I'll do 4, choose 1. Next, to get the number of jacks, the total number of jacks in the deck, there's 1 for each suit. So I know that n is 4, and I want to choose 2 of them. And same for kings. There's 1 king in every suit, so that means that there's 4 kings total, and I want to choose 2 of them. So this would be 4, choose 2 for both of these. Now to find the total number of possible outcomes, I multiply each of these events together. That gives me 144. Now that's not answering the question though, again, because it's probability. So I have 144 over my total number of outcomes, which was 2,598,000, that answer from Part A. That reduces to 3 over 54,145. That's a good answer if you have your number reduced. Or you could change it to a decimal, which is 0.000. Let's see. 4 zeros, 55. which as a percent, we just move my decimal place over 2. That's 0.006% chance of getting 1 ace, 2 jacks, and 2 kings. Okay, finally, last example I want to do together. Suppose there are 5 collies, 4 Dachshunds, and 6 retrievers at a vet's office. The doctor needs to choose 10 dogs out of the group to photograph for a lecture that he's giving about dog care. So since we're just talking about choosing dogs in a group, it doesn't matter what order we choose the dogs in, so I know that this is a combination problem. So for part A, they're asking how many ways can the 10 dogs be chosen? So the first thing I need to figure out is how many total dogs there are. There are 5, 4, and 6, so I'm going to add those up to get that there are 15 total dogs to choose from. R is how many dogs I want to choose. I want to choose 10 dogs. So to find the answer, I'm going to do 15, choose 10. That'll give you 3,003. Okay, part B says if the dogs are chosen randomly, what's the probability that 3 are collies, 3 are Dachshunds, and 4 are retrievers? So for this, I'm going to make 3 different events. Okay, so for the first one, collies, there are a total number of 5 collies, and I want to choose 3 of them. The next one, excuse me if I'm saying this wrong, but there are 4 Dachshunds, and I want to choose 3 of them. The last one, retrievers, there are 6 total to choose from, and I want to take 4 of them. So I'll do 5, choose 3, 4, choose 3, 6, choose 4, and to find the total number of possible outcomes, I multiply the number for the collies, Dachshunds, and retrievers together. This gives me 600, but notice they are asking for probability, so I need to take the 600, that's the number of outcomes in my favor, over the 3,003 that I got total number from part A. That reduces to 200 over 1,001. That as a decimal is 0.1998. So as a percent, that is about 20%, 19.98% probability. Either one of these answers is great. Okay, your homework for tonight is to correct your goal 1 and 2 homework problems and resubmit it. So if you got it right, just put a check mark on it. If not, follow through the video again. Make sure you have the correct answers written down. Take a picture, resubmit. Next, what I want you to do are your combination and permutation cards worksheet. Look in your email for directions on what you're doing here. Hope you have a great rest of your day. Sorry this video was kind of long. I wanted to make sure to explain each problem to you. I hope you have a great day. Bye, guys.